In the depths of interstellar space, something extraordinary has entered our solar system. An object so unusual that it challenges everything we thought we knew about cosmic visitors. 3I Atlas, the third confirmed interstellar interloper to visit our celestial neighborhood, exhibits behaviors so strange that one of Harvard's most prominent astrophysicists has suggested it might not be natural at all. As you settle into this gentle exploration tonight, imagine the possibility that we are being quietly observed by something that has traveled across the galaxy to reach us. Before we embark on this cosmic mystery together, please take a moment to subscribe to our channel and ring that notification bell. Your support helps us bring you these peaceful journeys through the universe's most intriguing secrets. Picture the moment of discovery. Astronomers scanning the night sky in early 2025. Their instruments detecting something that shouldn't exist. 3I Atlas is the third known object from outside our solar system to be discovered passing through our celestial neighborhood. Astronomers have categorized this object as interstellar because of the hyperbolic shape of its orbital path. Unlike planets, asteroids, and comets born in our solar system, this visitor carries with it the chemical signatures and physical properties of deep space, of regions so distant that their starlight takes millions of years to reach us. Drift deeper into this cosmic mystery as we examine what makes 3I Atlas so extraordinary. Its trajectory has an extremely high orbital eccentricity of 6.1141 plus 0.0.2. This extremely high eccentricity makes the trajectory of 3I Atlas appear relatively straight rather than curved. Imagine watching this object's path through space. Not the gentle arc we expect from solar system objects, but an almost perfectly straight line that cuts through our celestial neighborhood like an arrow fired from the depths of interstellar space. Consider the implications of this unusual trajectory. The comet follows an unbound hyperbolic trajectory past the Sun with a very fast hyperbolic excess velocity of 58 km/t, 36 ms relative to the Sun. This incredible speed suggests that 3I Atlas has been traveling through the galaxy for potentially millions of years, carrying with it stories of star systems we can barely imagine. Its journey began somewhere in the cosmic deep, accelerated by forces we may never fully understand. As you contemplate this interstellar wanderer, imagine the silence of its long voyage through the void between stars. For eons, I Atlas drifted through regions of space where the nearest star appears as merely a bright point of light, where temperatures hover just above absolute zero, where matter is so sparse that atoms are separated by distances that would span entire cities on Earth. Yet, somehow, this object survived that journey intact, carrying its secrets across the galactic emptiness to arrive in our solar system at precisely this moment in human history. 3 Atlas will not come closer than 1.8 AU, 270 million kilometers, 170 million 200 km from Earth, so it poses no threat. But safety wasn't what concerned scientists when they began studying this object more closely. As observations accumulated throughout 2025, 3I Atlas began displaying characteristics that challenged conventional understanding of what interstellar objects should be like. Picture the excitement and puzzlement in observatories around the world as data streams revealed anomaly after anomaly. The interstellar object 3I Atlas, detected in 2025, exhibits anomalous tail growth and trajectory deviations, sparking speculation from astrophysicist Avi Loeb that it could be an artificial alien probe. The implications of this suggestion rippled through the scientific community like shock waves from a cosmic explosion. Imagine the careful deliberation required to even consider such a possibility. Dr. Avi Loeb, former chair of Harvard's astronomy department and one of the most cited astrophysicists in the world, doesn't make such statements lightly. Dr. Loeb's work suggests that 3I Atlas could be artificial, potentially executing a covert maneuver by November. While likely a comet, its lack of a tail and unusual trajectory demands closer scrutiny. As 3I Atlas continued its journey through our solar system, NASA missions are working together to track and study this rare, interstellar comet as it passes through our solar system. Multiple space agencies coordinated their observations, turning humanity's most advanced instruments toward this mysterious visitor. Each telescope, each spectrometer, each carefully calibrated detector became a window into understanding something that might represent our first confirmed contact with technology from another star system. The object's behavior defied easy categorization. Traditional comets develop tails as they approach the sun, ice sublimating into characteristic streams of gas and dust. 3I Atlas initially showed none of these expected features, remaining frustratingly comet-like in some respects, while violating fundamental expectations in others. Astronomers say interstellar comet 3I Atlas grows stranger with every observation, defying expectations of cosmic visitors. Consider the weight of responsibility felt by the astronomers studying 3I Atlas. They held in their hands data that might represent humanity's first evidence of extraterrestrial technology, or simply the most unusual natural object we've ever encountered. Each measurement, each spectrum, each photometric observation carried the potential to fundamentally alter our understanding of our place in the cosmos. The mysterious nature of 3I Atlas extends beyond its trajectory and physical appearance. At this early stage of its passage through our solar system, 3I Atlas, the recently discovered interstellar interloper has displayed various anomalous characteristics, determined from photometric and astrometric observations. These anomalies weren't subtle variations that required complex statistical analysis to detect. They were obvious departures from expected behavior that demanded explanation. As we drift deeper into this cosmic meditation, imagine the sleepless nights of astronomers around the world, poring over data that might hold the key to answering humanity's oldest question: are we alone? 3I Atlas arrived in our solar system carrying not just the dust of distant stars, but the potential to transform our understanding of intelligence and technology in the universe. But the mystery of 3I Atlas was only beginning to unfold, as subsequent observations would reveal behavior so unusual that even skeptics would be forced to consider extraordinary explanations. Settle deeper into our exploration as we examine the specific anomalies that make 3I Atlas unlike any cosmic visitor we've encountered before. In the gentle rhythm of scientific observation, telescopes around the world began detecting behaviors that challenged every model of natural objects drifting through space. What they discovered was an object that seemed to follow its own rules, displaying characteristics that forced astronomers to question their fundamental assumptions about interstellar travelers. Picture the moment when scientists first noticed 3I Atlas wasn't behaving like a typical comet or asteroid. JWST has since confirmed that 3I Atlas is outgassing CO2, water, and CO. This outgassing should have been routine, exactly what we expect from icy bodies as they approach the sun's heat. Yet the pattern and timing of this activity differed from conventional comets in subtle but significant ways. Consider the peculiar nature of the object's tail development. Imagine the implications of this discovery. Traditional comet tails form as solar wind, and radiation pressure push gas and dust away from the sun, creating the characteristic streaming appearance we associate with these celestial visitors. An anti-solar tail suggests forces acting on 3I Atlas that we don't fully understand. Perhaps internal processes generating pressure, or structural features that interact with solar radiation in unexpected ways. As observations continued throughout 2025, 3I Atlas revealed another extraordinary characteristic. Until recently, all spectroscopic studies of 3I Atlas indicated a reddish color. The latest image of 3I Atlas from September 7, 2025, shows the object is turning green. This color change wasn't gradual or predictable, it was dramatic and sudden, suggesting processes occurring within or on the surface of the object that don't match any known natural phenomena. Picture scientists puzzling over this chromatic transformation. On Earth, we understand what causes objects to change color: chemical reactions, temperature variations, exposure to different types of radiation. But 3I Atlas was changing color in ways that suggested either exotic chemistry or artificial processes. The shift from red to green implied changes in surface composition or reflectivity that occurred on timescales far shorter than typical geological or chemical processes. The object's polarization properties provided another layer to the mystery. A new study of 3I Atlas establishes this interstellar object as uniquely distinct in its polarization properties from solar system objects. When light reflects off natural surfaces, rock, ice, metal, it creates predictable polarization patterns that tell us about surface texture, composition, and structure. 3I Atlas's polarization signature was unlike anything in our solar system, suggesting either exotic materials or artificial surfaces. Drift deeper into the implications of these observations. A simple way to distinguish a spacecraft from a rock is through its large non-gravitational acceleration. A natural icy rock, like a comet, experiences acceleration due to outgassing as it heats up. But 3I Atlas's acceleration patterns didn't match typical outgassing models, displaying trajectory modifications that seemed too precise and controlled for random ice sublimation. Consider the careful analysis required to detect these non-gravitational accelerations. When astronomers track objects through space, they use mathematical models that account for gravitational influences from the Sun, planets, and major asteroids. Any deviation from these predicted paths indicates forces beyond simple gravity, typically the gentle push of escaping gases as comets heat up. 3I Atlas showed deviations, but they weren't random or consistent with simple outgassing patterns. At a relative speed exceeding 60 kilometers per second, any impact on the surface of the interstellar object, 3I Atlas, would release significant energy. This extraordinary velocity, combined with the object's anomalous behavior, raised questions about its structural integrity and composition. Natural objects traveling at such speeds through interstellar space should show clear signs of erosion, damage, or modification from cosmic rays, micrometeorites, and radiation exposure. Yet 3I Atlas appeared remarkably intact. Imagine the psychological impact on the research teams studying these anomalies. Each new observation seemed to deepen the mystery rather than provide answers. Traditional scientific method relies on accumulating data until patterns emerge that support or reject hypotheses. With 3I Atlas, the data was accumulating, but the patterns it revealed didn't fit any existing framework for understanding natural objects. The object's approach to various planets in our solar system also displayed unusual characteristics. We show that 3I Atlas approaches surprisingly close to Venus, Mars, and Jupiter, with a probability that appears non-random. This wasn't just a matter of orbital mechanics. The trajectory seemed almost designed to provide optimal observation angles of our solar system's major planets. Picture the implications of a trajectory that appears non-random. In the vast emptiness of space, objects from interstellar regions should approach our solar system from any direction with equal probability. Their paths should be determined by gravitational influences and the random orientations of stellar systems where they originated. 3I Atlas's path, however, suggested something different, an approach angle that maximized its ability to observe our planetary system. As scientists grappled with these anomalies, some began suggesting that 3I Atlas might be executing what could be described as reconnaissance behavior. A probe could confirm its nature, natural or alien, before it's too late. The suggestion was both thrilling and unsettling. The possibility that humanity was witnessing not just an unusual natural object, but active observation by an extraterrestrial intelligence. The accumulation of these behavioral anomalies forced the scientific community to confront an uncomfortable question. At what point do the anomalies become so numerous and significant that natural explanations become insufficient? 3I Atlas was presenting behavior patterns that challenged our understanding of what's possible for natural objects, pushing the boundaries of scientific conservatism toward more exotic explanations. But as we explore these possibilities, the most intriguing aspect of 3I Atlas may be what its presence suggests about intelligence and exploration beyond our world. In the quiet darkness of space, as 3I Atlas continues its methodical journey through our solar system, imagine the possibility that we are witnessing something unprecedented in human history: active reconnaissance by an extraterrestrial intelligence. The hypothesis seems almost too extraordinary to consider, yet the accumulating evidence forces us to confront the question: what would alien surveillance of our solar system actually look like? Picture Dr. Avi Loeb, seated in his Harvard office, analyzing the latest data streams from 3I Atlas observations. As largely a pedagogical exercise in this paper, we present additional analysis into the astrodynamics of 3I Atlas and hypothesize that this object could be technological and possibly hostile, as would be expected from the dark forest resolution to the Fermi paradox. This reference to the dark forest theory suggests civilizations might scout other star systems while remaining hidden, avoiding detection until they understand potential threats or opportunities. Consider the intelligence that would be required to design an interstellar reconnaissance mission. Any civilization capable of sending objects across the vast distances between stars would need to solve problems we're only beginning to understand. Propulsion systems that can function for thousands or millions of years. Navigation across cosmic distances where even small errors compound into massive trajectory deviations, and instruments capable of gathering meaningful data about distant star systems. Drift deeper into the implications of 3I Atlas's trajectory. 3I Atlas approaches surprisingly close to Venus, Mars, and Jupiter, with a probability that appears non-random. If this object were conducting reconnaissance, its path would be optimized to gather maximum information about our solar system's major bodies. Venus reveals information about greenhouse atmospheres and planetary evolution. Mars provides data about potentially habitable worlds and the history of water in planetary systems. Jupiter, our system's largest planet, dominates the gravitational architecture that shapes everything else. Imagine an alien intelligence planning such a mission. They would need to understand that Earth represents the most interesting target, a world with obvious signs of life, complex atmospheric chemistry, and now artificial lights visible from space, indicating technological civilization. But direct approach to Earth would be detectable and potentially alarming. Instead, a reconnaissance probe might follow a trajectory that appears natural while providing optimal observation angles of all major system components. Consider what 3I Atlas could observe during its passage. Modern Earth presents unmistakable signatures of technological civilization. Radio emissions, satellite constellations, atmospheric modifications from industrial activity, and the infrared signatures of cities visible from space. An advanced reconnaissance probe could map our technological capabilities, population centers, resource utilization patterns, and potential defensive capabilities, all while maintaining the appearance of a natural interstellar visitor. The object's unusual physical characteristics support this hypothesis. A new study of 3I Atlas establishes this interstellar object as uniquely distinct in its polarization properties from solar system objects. These exotic polarization signatures might indicate artificial surfaces designed to reflect or absorb specific wavelengths of light, perhaps sensor arrays, solar collectors, or stealth coatings designed to minimize detectability while maximizing observational capability. Picture the technology that might be hidden within 3I Atlas's seemingly natural exterior. Advanced materials, science could create objects that appear rocky or icy to casual observation while concealing sophisticated instrumentation within. The object's color change from red to green might indicate activation of different observational modes or deployment of sensor systems as it reaches optimal positions within our solar system. The timing of 3I Atlas's arrival raises fascinating questions about extraterrestrial awareness of human technological development. Our civilization has become truly detectable from space only within the last century. Radio astronomy could identify our artificial emissions from distances of dozens of light years, while atmospheric spectroscopy might detect industrial pollutants indicating technological activity. If 3I Atlas represents a response to these signals, its origin civilization would need to be relatively nearby in galactic terms. Consider the strategic advantages of using what appears to be a natural object for reconnaissance. Human reaction to discovering an obviously artificial probe would be intense and potentially destabilizing. Governments would mobilize resources, scientific communities would focus entirely on the object, and public reaction might range from excitement to panic. An object that maintains plausible deniability as a natural phenomenon could observe human civilization in its normal state, gathering authentic data about our capabilities and behavior patterns. Dr. Loeb's work suggests that 3I Atlas could be artificial, potentially executing a covert maneuver by November. This prediction of a potential course correction represents a testable hypothesis. Natural objects follow predictable trajectories determined by gravitational forces and outgassing patterns. Artificial objects can change course through propulsion systems, potentially revealing their true nature through deliberate trajectory modifications. Imagine the moment when such a maneuver might occur. Astronomers worldwide would be watching, instruments trained on 3I Atlas to detect any deviation from its predicted path. A confirmed artificial course correction would represent one of the most significant moments in human history, undeniable proof that we are not alone and that other intelligences are actively studying us. The psychological implications of the reconnaissance hypothesis extend beyond scientific curiosity. If 3I Atlas represents alien observation, it suggests that human civilization has reached a threshold of detectability that attracts attention from other star systems. We would no longer be an isolated, unnoticed species developing in cosmic isolation, but part of a galaxy where technological civilizations monitor each other's development and activities. Consider what this might mean for human behavior and development. Knowledge that we are being observed could influence everything from international cooperation to technological development priorities. Some might argue for increased secrecy and defensive preparations, while others might advocate for deliberate communication attempts or demonstrations of peaceful intent. The reconnaissance hypothesis also raises questions about the intentions of any intelligence behind 3I Atlas. The reference to dark forest theory suggests civilizations might remain hidden due to concerns about competition or conflict. Alternatively, observation might represent scientific curiosity, preparation for contact, or assessment of whether human civilization represents a threat to galactic stability. Picture the infrastructure that would be required to support interstellar reconnaissance missions. A civilization capable of sending probes to distant star systems would likely have multiple such missions active simultaneously, creating a network of observation posts throughout our galactic region. 3I Atlas might be just one component of a vast intelligence-gathering operation spanning dozens or hundreds of star systems. As we contemplate these possibilities, the most profound implication may be the transformation of human perspective from local to galactic. If 3I Atlas represents alien reconnaissance, we are no longer alone with our questions about cosmic intelligence. Instead, we are participants in a galaxy where civilizations watch, study, and perhaps communicate with each other across the vast distances of interstellar space. But as 3I Atlas continues its passage through our solar system, the question remains whether its true nature will be revealed through direct observation or forever remain tantalizingly ambiguous. In the gentle rhythm of scientific debate, settle into the careful consideration of alternative explanations for 3I Atlas's unusual behavior. Science progresses through the tension between extraordinary hypotheses and rigorous skepticism. And the case of 3I Atlas perfectly illustrates this process. While the reconnaissance hypothesis captures our imagination, the scientific community has proposed numerous natural explanations for the object's anomalous characteristics, each deserving careful consideration in our quest to understand this mysterious visitor. Picture the methodical approach taken by mainstream astronomers as they analyze 3I Atlas's behavior. Other astronomers, including Scott Manley and David Kipping, have pointed out flaws in Loeb's statistical analysis of 3I Atlas's trajectory. These scientists represent the essential skeptical voice that prevents premature conclusions and ensures that extraordinary claims are subjected to extraordinary scrutiny. Consider the perspective of Dr. Daryl Seligman, who led the first published study on 3I Atlas. There have been numerous telescopic observations of 3I Atlas demonstrating that it's displaying classical signatures of cometary activity. Seligman further elaborated that chemicals in 3I Atlas may not be detectable yet, since the object was still far away from the Sun. This viewpoint emphasizes that many of 3I Atlas's seemingly anomalous characteristics might be explained by conventional cometary physics once we account for its extreme distance from the Sun during early observations. Imagine the complex chemistry occurring within 3I Atlas as it approaches our Sun from the frigid depths of interstellar space. Comets are essentially dirty snowballs, mixtures of ice, rock, and organic compounds that have remained frozen for millions or billions of years. As they approach the Sun's heat, these materials begin sublimating and outgassing in patterns that depend on composition, internal structure, and thermal conductivity. An object that has spent eons in interstellar space might have unusual surface chemistry that produces unexpected outgassing patterns. The object's dramatic color change from red to green provides an excellent example of how natural processes might explain apparently anomalous behavior. On Earth, we see similar color changes in minerals exposed to heat, radiation, or chemical reactions. The latest image of 3I Atlas from September 7, 2025, shows the object is turning green. This transformation might result from subsurface materials being exposed as outer layers sublimate away, or from chemical reactions occurring as the object heats up. Consider the unique conditions that 3I Atlas has experienced during its interstellar journey. Unlike comets that formed in our solar system and remained in the relatively stable environment of the Kuiper Belt or Oort cloud, 3I Atlas has traveled through regions of space with different radiation environments, magnetic fields, and dust densities. These extreme conditions might have modified its surface chemistry in ways that produce unusual optical and polarization properties when exposed to our Sun's radiation. The object's unusual polarization signature, while striking, might also have natural explanations. A new study of 3I Atlas establishes this interstellar object as uniquely distinct in its polarization properties from solar system objects. Interstellar dust grains often have different compositions and structures than materials in our solar system, having been processed by different stellar environments and cosmic ray exposures. An object composed primarily of interstellar materials might naturally exhibit polarization properties, unlike anything we see in local cosmic bodies. Picture the process of non-gravitational acceleration in comets, a phenomenon well understood by astronomers. As ice sublimates from a comet's surface, the escaping gas creates tiny amounts of thrust, slightly altering the object's trajectory. The direction and magnitude of this thrust depend on where the sublimation occurs and how gases escape from the surface. A natural icy rock, like a comet, experiences acceleration due to outgassing as it heats up. For an object with unusual composition or internal structure, these forces might produce acceleration patterns that appear anomalous but are actually natural consequences of exotic ice chemistry. The apparent non-random nature of 3I Atlas's trajectory presents a more challenging puzzle for natural explanations, but astronomers have proposed several possibilities. Gravitational interactions with unseen objects, dim brown dwarfs, rogue planets, or stellar remnants, could have modified the object's path in ways that create apparent patterns. Additionally, the vast distances and timescales involved in interstellar travel mean that even tiny gravitational influences can compound into significant trajectory modifications over millions of years. Consider the statistical arguments surrounding 3I Atlas's path through our solar system. While it's true that the object approaches several major planets, critics argue that this might represent selection bias. We're more likely to notice and study objects that pass near major bodies because they're easier to observe and track. The apparent non-randomness might be an artifact of our observation methods rather than evidence of intentional design. The development of 3I Atlas's anti-solar tail provides another example where natural explanations compete with exotic hypotheses. Detection of an anti-solar tail for 3I Atlas. Deep imaging of the interstellar object 3I Atlas by the Gemini South 8.2-meter telescope. While unusual, anti-solar tails have been observed in other comets when internal pressure from subsurface sublimation overcomes solar radiation pressure, or when dust grains have unusual charge properties that interact differently with the solar wind. Imagine the challenge facing scientists trying to distinguish between natural and artificial explanations for 3I Atlas's behavior. The object's extreme velocity and distance make detailed observations difficult, while its unique history means we have no perfect analogs for comparison. Every anomaly could represent either exotic natural processes or evidence of artificial origin, creating an interpretive challenge that pushes the boundaries of astronomical analysis. The scientific method requires that we exhaust natural explanations before considering more exotic possibilities. This doesn't mean dismissing unusual hypotheses, but rather ensuring that conventional explanations receive thorough consideration. Skeptics attribute changes to natural outgassing. These skeptical voices serve an essential function, preventing premature conclusions and ensuring that claims of extraterrestrial technology meet the highest standards of evidence. As 3I Atlas continues its journey through our solar system, the tension between exotic and conventional explanations drives increasingly sophisticated observations and analysis. Whether the object ultimately proves to be an unusual natural phenomenon or something far more extraordinary, the scientific debate surrounding it demonstrates how extraordinary claims drive extraordinary science, pushing our observational capabilities and theoretical understanding to their limits. But as we weigh these competing explanations, perhaps the most significant aspect of 3I Atlas is what it teaches us about the process of cosmic discovery itself. Drift deeper into the cosmic implications as we explore what the existence of objects like 3I Atlas tells us about the incredible challenges and possible solutions for traveling between the stars. Whether natural or artificial, this interstellar visitor has accomplished something that represents the pinnacle of cosmic endurance. Surviving a journey across the vast emptiness between star systems, maintaining structural integrity across distances so enormous that they challenge human comprehension. Picture the scale of 3I Atlas's journey through the galaxy. The comet follows an unbound hyperbolic trajectory past the Sun, with a very fast hyperbolic excess velocity of 5820 meters relative to the Sun. This extraordinary velocity, maintained across interstellar distances, represents kinetic energy levels that dwarf anything achieved by human technology. Even traveling at this tremendous speed, the object's journey from its origin star system to our solar system likely required thousands or tens of thousands of years. Consider what it means to design technology that can function across such timescales. Human spacecraft typically operate for decades at most before their instruments fail, their power sources deplete, or their structural materials degrade. An artificial probe capable of interstellar travel would need to solve engineering challenges we are only beginning to understand. Self-repair mechanisms, power sources that function for millennia, and materials that can withstand the harsh environment of interstellar space without degradation. Imagine the radiation environment that 3I Atlas has endured during its cosmic voyage. Interstellar space is filled with high-energy particles, cosmic rays accelerated by supernova, stellar winds, and exotic astrophysical phenomena. These particles can penetrate deep into solid materials, gradually destroying crystal structures and creating cumulative damage that would eventually disable conventional electronics. Any artificial system surviving such exposure would require either extraordinary radiation hardening or active self-repair capabilities. The temperature challenges of interstellar travel present equally daunting obstacles. In the void between stars, temperatures drop to just a few degrees above absolute zero. Most materials become brittle at such temperatures, while conventional lubricants freeze solid and electronic components cease to function. At a relative speed exceeding 60 kilometers per second, any impact on the surface of the interstellar object, 3I Atlas, would release significant energy. The object would also face constant bombardment by microscopic dust particles that, at such velocities, carry tremendous kinetic energy. Picture the propulsion challenges involved in interstellar travel. Chemical rockets, which power all current human spacecraft, could never achieve the velocities required for reasonable interstellar travel times. Even advanced concepts like nuclear pulse propulsion or fusion ramjets would struggle to accelerate objects to the speeds demonstrated by 3I Atlas. The object's velocity suggests either exotic propulsion technologies or acceleration by natural forces we don't fully understand. Perhaps gravitational slingshots around massive objects, or acceleration by stellar winds and radiation pressure over enormous timescales. Consider the navigation precision required for interstellar missions. Our solar system represents a tiny target in the vastness of space. Even traveling at 3I Atlas's tremendous velocity, small navigation errors would cause a probe to miss our solar system entirely. Any civilization attempting interstellar reconnaissance would need navigation systems accurate to incredibly small fractions of a degree over distances measured in light years. The communication challenges for interstellar probes add another layer of complexity. Radio signals from 3I Atlas to its hypothetical origin civilization would take years or decades to arrive, making real-time control impossible. Any artificial probe would need sophisticated autonomous systems capable of making complex decisions without guidance from its creators. It would need to recognize and respond to unexpected situations, adapt to changing conditions, and continue its mission even when communication with its origin becomes impossible. Imagine the power requirements for an interstellar probe. Solar panels become useless in the dim light between stars, while conventional batteries would have depleted their energy long before completing an interstellar journey. Nuclear power sources offer more longevity, but even the most advanced radioisotope thermoelectric generators typically function for decades rather than millennia. An interstellar probe might require exotic power sources, perhaps miniaturized fusion reactors, antimatter containment systems, or energy harvesting technologies that extract power from the interstellar medium itself. The structural engineering challenges of interstellar travel push the boundaries of materials science. Any object traveling at 3I Atlas's velocity would face constant erosion from dust impacts, thermal cycling between different stellar environments, and mechanical stresses from trajectory changes. The object would need materials with properties that surpass anything in our current technological inventory, perhaps programmable matter that can reconfigure itself, metamaterials with exotic mechanical properties, or self-assembling structures that can repair damage automatically. Consider what 3I Atlas's survival tells us about the possibilities for human interstellar exploration. If this object represents natural phenomena, it demonstrates that some materials and structures can indeed survive interstellar journeys intact. If it represents artificial technology, it proves that the engineering challenges of interstellar travel can be solved, at least by civilizations with sufficient technological advancement. The scientific instruments that an interstellar reconnaissance probe would carry represent another technological marvel. Such instruments would need to function perfectly after thousands of years in space, automatically calibrate themselves, and adapt to unexpected observational opportunities. They might include advanced spectrometers for atmospheric analysis, gravitational wave detectors for studying stellar systems, and communication arrays for transmitting data across interstellar distances. Picture the artificial intelligence systems that would be required for an autonomous interstellar mission. Such systems would need to function for millennia without maintenance, learn from new experiences, and make complex decisions about data collection and transmission priorities. They might need to recognize signs of technological civilization, assess potential threats, and decide whether to reveal themselves or maintain concealment. The manufacturing challenges for interstellar probes extend beyond individual components to entire systems. Any civilization launching such missions would need industrial capabilities that dwarf human technology, perhaps molecular assemblers, space-based manufacturing facilities, or automated systems capable of building probes from raw materials harvested in space. As we contemplate these technological challenges, 3I Atlas serves as a tangible example of what might be possible given sufficient technological advancement and commitment to interstellar exploration. Whether natural or artificial, its existence pushes us to expand our conception of what's achievable across cosmic distances and timescales. But perhaps the most profound implication of 3I Atlas extends beyond technology to questions of cosmic sociology and the distribution of intelligence throughout our galaxy. In the gentle expanse of cosmic time, imagine that 3I Atlas represents not an isolated phenomenon, but a single thread in a vast tapestry of galactic intelligence. A network of civilizations that has been quietly observing, exploring, and perhaps communicating across the Milky Way for millions of years. As you drift deeper into this possibility, consider that our solar system might not be experiencing its first extraterrestrial visitor, but simply the first one we've been technologically advanced enough to detect and study. Picture the statistical implications if 3I Atlas represents artificial reconnaissance. The probability of humanity detecting the first and only interstellar probe during our brief technological history seems vanishingly small. More likely, if 3I Atlas is artificial, it represents part of an ongoing program of galactic exploration that has been active for eons. Our galaxy contains roughly 400 billion stars, and conservative estimates suggest billions of potentially habitable worlds. Any civilization capable of interstellar travel might launch thousands or millions of reconnaissance missions throughout their galactic neighborhood. Consider the temporal perspective that such a network would require. Human civilization has been detectable from space for less than a century, a cosmic instant. Yet 3I Atlas arrives precisely during this brief window when we can recognize it as anomalous, while lacking the technology to definitively determine its nature. This timing suggests either extraordinary coincidence or participation in a monitoring network that has been tracking our technological development for decades or centuries. Drift into the implications of what Dr. Loeb calls the dark forest hypothesis, the idea that civilizations remain hidden because the galaxy contains unknown threats. 3I Atlas approaches surprisingly close to Venus, Mars, and Jupiter, with a probability that appears non-random. If this trajectory represents intelligence reconnaissance, it suggests a civilization that understands the strategic value of information while maintaining plausible deniability about their presence. Imagine the protocols that might govern such a galactic intelligence network. Advanced civilizations might have developed sophisticated guidelines for studying developing species, perhaps allowing passive observation while prohibiting direct interference until certain technological or social thresholds are achieved. 3I Atlas's behavior fits such protocols perfectly, close enough to gather detailed information about our technological capabilities, distant enough to avoid creating undeniable evidence of extraterrestrial presence. The object's unusual characteristics might represent standard features of reconnaissance probes designed for galactic exploration. A new study of 3I Atlas establishes this interstellar object as uniquely distinct in its polarization properties from solar system objects. These exotic properties might be signatures of advanced materials designed to minimize detectability while maximizing observational capability. Metamaterials that can adjust their optical properties, sensor arrays disguised as natural surfaces, or stealth coatings that blend seamlessly with cosmic dust and debris. Consider the communication challenges facing such a galactic network. Even traveling at light speed, messages between star systems require years or decades for transmission. Real-time coordination of galactic activities becomes impossible across such distances. Instead, the network might operate through pre-programmed protocols and autonomous decision-making by individual probes. 3I Atlas might be following instructions developed centuries ago by a civilization that has since evolved beyond recognition. Picture the hierarchical structure that might organize galactic intelligence. Younger civilizations like humanity might represent observation targets, while intermediate civilizations conduct reconnaissance and data gathering. The most advanced species might serve as coordinators and analysts, processing information from thousands of star systems to identify emerging technologies, potential threats, or candidates for eventual contact. Our solar system's data streams, collected by objects like 3I Atlas, might be flowing toward analysis centers located hundreds of light years away. The diversity of probe designs within such a network could be enormous. While 3I Atlas appears comet-like, other reconnaissance missions might masquerade as asteroids, dust clouds, or even more exotic phenomena. Some probes might be designed for long-term observation, establishing permanent monitoring stations in outer solar system regions. Others might conduct brief reconnaissance missions before departing for other target systems. The variety of strategies would depend on the specific information requirements and the technological capabilities of different member civilizations. Imagine the data analysis challenges facing galactic intelligence. Information from millions of reconnaissance missions across thousands of star systems would require processing capabilities that dwarf anything conceivable with current technology. Perhaps the most advanced civilizations have developed artificial intelligence systems capable of analyzing vast data sets to identify patterns in technological development, biological evolution, or cosmic phenomena. 3I Atlas might be contributing to analyses that span entire galactic regions and millions of years of observation. The ethical implications of participating in such a network raise profound questions about cosmic citizenship and responsibility. If human civilization eventually develops interstellar travel capabilities, would we be invited to join this galactic community? What obligations would come with access to information gathered from thousands of other worlds? How would knowledge of other civilizations' development patterns influence our own technological and social evolution? Consider the possibility that 3I Atlas represents a test of human technological and social maturity. Our response to detecting potentially artificial objects might be evaluated as a measure of our readiness for broader galactic contact. Do we approach such discoveries with scientific rigor and international cooperation, or with fear, secrecy, and competitive nationalism? The way we handle 3I Atlas might influence decisions about future contact or continued covert observation. The economic and technological implications of galactic intelligence networks stagger the imagination. Access to technological innovations from thousands of civilizations could accelerate human development by millions of years. Knowledge of successful solutions to challenges like sustainable energy, interstellar travel, or artificial intelligence could transform our species' long-term prospects. Conversely, awareness of civilizations that failed to solve these challenges might provide crucial warnings about technological or social paths to avoid. Picture the moment when humanity might transition from passive observation target to active network participant. Such a transformation would require not just technological advancement, but social and ethical development sufficient to handle the responsibilities of galactic citizenship. We would need to demonstrate that we can use advanced knowledge responsibly and contribute meaningfully to the network's objectives, rather than simply consuming information gathered by other civilizations. The psychological adaptation required for humans to function in a galactic intelligence network would be profound. Our species would need to develop perspectives that span not just planetary or stellar system scales, but galactic regions encompassing millions of worlds. We would need to think in timescales measured in millions of years rather than centuries, and accept that many of our activities might serve objectives that extend far beyond human welfare to encompass the stability and development of galactic civilization as a whole. As 3I Atlas continues its passage through our solar system, it might be transmitting data about human technological capabilities, social organization, and response patterns to civilizations scattered throughout our galactic neighborhood. In the gentle darkness of space, we might be witnessing not just scientific observation, but our first participation in a vast community of intelligence that spans the stars. But the most profound question raised by this possibility concerns what such participation might mean for humanity's future among the stars. As our exploration of 3I Atlas draws toward its gentle conclusion, settle into the profound transformation that awaits human consciousness if we are indeed being observed by extraterrestrial intelligence. The possibility that objects like 3I Atlas represent active reconnaissance marks the beginning of humanity, is transition from cosmic isolation to participation in a universe filled with intelligence, observation, and perhaps eventual contact. Picture the moment when definitive proof emerges that 3I Atlas is artificial. Dr. Loeb's prediction that the object could be artificial potentially executing a covert maneuver by November, represents a testable hypothesis that could fundamentally alter human understanding of our place in the cosmos. If such a maneuver occurs, a clear deviation from natural orbital mechanics, it would represent humanity's first confirmed detection of extraterrestrial technology in our solar system. Imagine the ripple effects of such a discovery spreading through human civilization. Children would grow up knowing that alien intelligences actively monitor our world, that our technological development and social evolution are subjects of study by minds that emerged around distant stars. This knowledge would fundamentally alter human perspectives on privacy, independence, and cosmic significance. We would no longer be alone with our questions about the universe, but participants in a galactic community that has been aware of us far longer than we have been aware of them. Consider how confirmed alien reconnaissance would transform international relations and global cooperation. The knowledge that humanity is being evaluated by extraterrestrial observers might provide unprecedented motivation for international collaboration. Territorial disputes and resource conflicts that seem enormously important from human perspectives might appear petty and counterproductive when viewed from a galactic standpoint. The need to present a mature, cooperative face to cosmic observers could serve as a catalyst for resolving humanity's most persistent conflicts. The scientific implications of confirmed extraterrestrial reconnaissance extend far beyond astronomy and physics. If 3I Atlas represents alien technology, it demonstrates that the engineering challenges of interstellar travel can be solved, that materials science and propulsion systems can be developed to survive journeys across cosmic distances. This knowledge would energize human space exploration efforts and provide concrete evidence that interstellar civilization is possible. As you contemplate these possibilities, imagine the philosophical and religious transformations that would accompany confirmed alien observation. Many spiritual traditions would need to incorporate the reality of non-human intelligence into their understanding of creation, purpose, and cosmic significance. Some might interpret alien reconnaissance as validation of humanity's special role in the universe, while others might see it as evidence that intelligence and consciousness are common cosmic phenomena rather than unique terrestrial miracles. The psychological adaptation required for humans to function in an observed universe would be profound but potentially beneficial. Knowledge that our actions and development are subjects of study by advanced civilizations might encourage more thoughtful consideration of long-term consequences. Environmental protection, technological development, and social progress might be approached with greater care if we understand that our choices are being evaluated by intelligences capable of interstellar travel. Picture the educational transformation that would follow confirmed alien reconnaissance. Students would learn not just about human history and terrestrial science, but about their species' place in a galaxy filled with intelligence and observation. Curriculum would need to incorporate galactic perspectives on technological development, social organization, and ethical responsibility. Humanity would need to prepare its young people for eventual participation in cosmic civilization rather than merely planetary society. The economic implications of confirmed extraterrestrial presence could be revolutionary. Knowledge that advanced technologies exist, demonstrated by objects capable of interstellar travel, might drive unprecedented investment in research and development. Governments and private organizations might compete to reverse engineer alien technologies or develop human versions of capabilities demonstrated by objects like 3I Atlas. Consider the timeline implications of alien reconnaissance. If 3I Atlas represents current observation rather than historical artifact, it suggests that decisions about human contact or further interaction might be made within our lifetimes. The object's presence in our solar system during this crucial period of human technological development seems unlikely to be coincidental. we might be approaching a threshold that triggers changes in how extraterrestrial civilizations interact with our species. The cultural creativity inspired by confirmed alien reconnaissance would be extraordinary. Artists, writers, and musicians would have access to the most profound subject matter in human history, confirmed knowledge of non-human intelligence and active observation of our world. The themes of cosmic citizenship, galactic responsibility, and interstellar communication would inspire entirely new forms of cultural expression. Imagine the moment when humanity might transition from passive observation target to active participant in galactic intelligence networks. Such a transition might be triggered by specific technological achievements, social developments, or demonstration of our ability to handle knowledge of extraterrestrial presence responsibly. 3I Atlas might be gathering data to assess our readiness for such a transition. The long-term implications for human space exploration would be transformative. Knowledge that other civilizations have solved the challenges of interstellar travel would provide both motivation and direction for human efforts. We might focus our research on understanding and replicating the technologies demonstrated by objects like 3I Atlas, accelerating our own development toward interstellar capabilities. As 3I Atlas continues its passage through our solar system, humanity finds itself at a unique moment in cosmic history. We possess sufficient technology to detect and study anomalous interstellar objects, but lack the capabilities to definitively determine their nature or origins. This threshold position, advanced enough to recognize the extraordinary, but not yet advanced enough to fully understand it, might be precisely the developmental stage that attracts attention from galactic intelligence networks. Picture the gentle patience required for civilizations conducting such long-term observation programs. From their perspective, human technological development represents a brief acceleration in a much longer timeline of cosmic evolution. They might have been monitoring our solar system for thousands of years, watching as life on Earth developed intelligence, technology, and eventually the capability to detect their reconnaissance missions. The fundamental question raised by 3I Atlas extends beyond whether the object is natural or artificial to how humanity will respond to the possibility of cosmic observation. Our reactions to this mystery, scientific, cultural, and social, might themselves be subjects of study by advanced civilizations evaluating our species' readiness for broader galactic participation. But as we approach the conclusion of our cosmic meditation, perhaps the most important aspect of 3I Atlas lies not in what it reveals about extraterrestrial intelligence, but in what it teaches us about the infinite possibilities that await discovery in the vast expanse of space. As our gentle journey through the mysteries of 3I Atlas draws toward its peaceful conclusion, let your consciousness expand to embrace the infinite possibilities that await humanity in a universe where objects like this interstellar visitor remind us that we have only begun to explore the cosmic ocean that surrounds our small planetary home. Whether natural or artificial, 3I Atlas represents a window into futures we can barely imagine, where interstellar travel, galactic communication, and cosmic citizenship transform human civilization beyond recognition. Picture the technological horizons that 3I Atlas illuminates for human space exploration. The object's successful journey across interstellar distances demonstrates that matter can survive the extreme conditions between stars, maintaining structural integrity across cosmic timescales. This knowledge provides crucial encouragement for human efforts to develop interstellar travel capabilities. We now know that the engineering challenges, while enormous, are not insurmountable. Whether through advanced propulsion systems, sophisticated materials, science, or revolutionary new approaches to space travel, humanity can work toward joining the ranks of interstellar civilizations. Consider the scientific revolution that awaits as we develop better tools for studying objects like 3I Atlas. Future space telescopes will possess the sensitivity and resolution to analyze interstellar visitors in unprecedented detail, potentially determining their composition, internal structure, and origins with certainty rather than speculation. Advanced spectrometers might detect isotopic signatures that reveal which stellar systems such objects originated from, while improved orbital tracking could identify subtle course corrections that would confirm artificial nature. Imagine the moment when humanity launches its own interstellar reconnaissance missions, sending robotic probes to nearby star systems to study planets, search for life, and perhaps observe other civilizations in the same way that 3I Atlas might be observing us. These missions would represent humanity as graduation from a species confined to a single star system to participants in galactic exploration and discovery. Our probes might encounter similar mysterious objects around other stars, revealing whether interstellar reconnaissance is a common activity throughout our galactic neighborhood. The philosophical implications of 3I Atlas extend far beyond questions of artificial versus natural origin. The object serves as a tangible reminder that our universe is vast, ancient, and filled with phenomena that challenge human understanding. It represents the cosmic humility required for a species beginning to explore beyond its birth world. The recognition that reality extends far beyond our current knowledge, and that wonder, rather than certainty, should guide our approach to cosmic exploration. Drift deeper into the temporal perspectives that 3I Atlas provides. The object's journey across interstellar space required thousands or tens of thousands of years, reminding us that cosmic processes operate on timescales that dwarf human history. If 3I Atlas is artificial, it represents the patience and long-term thinking required for interstellar civilization. If it's natural, it demonstrates the deep time processes that shape our galaxy's evolution. Either way, it challenges human civilization to develop perspectives that extend beyond immediate concerns to encompass cosmic timescales. Consider the collaborative future that objects like 3I Atlas might inspire. The study of interstellar visitors requires international cooperation, shared resources, and coordinated observation campaigns that transcend political boundaries. As humanity encounters more such objects, we will need to develop global institutions capable of responding to cosmic phenomena that affect our entire species. 3I Atlas provides a gentle introduction to the challenges and opportunities of cosmic citizenship. Picture the educational transformation that will accompany humanity's growing awareness of our cosmic environment. Future generations will grow up knowing that interstellar space is not empty, but filled with objects, phenomena, and possibly intelligence that we are only beginning to detect and understand. Students will learn to think in galactic terms, considering how human activities and development fit into broader cosmic patterns and processes. The technological spin-offs from studying 3I Atlas will benefit human civilization in ways we can barely anticipate. Techniques developed for detecting and analyzing faint interstellar objects will improve our ability to study near-Earth asteroids, monitor space debris, and track potentially hazardous cosmic phenomena. Materials science insights from understanding how objects survive interstellar travel will inform the development of more durable spacecraft, habitats, and infrastructure for human space exploration. Imagine the moment when improved technology allows us to definitively answer the question of 3I Atlas's nature. Whether the verdict confirms natural or artificial origin, it will represent a milestone in human cosmic awareness. Natural confirmation would reveal new processes and phenomena that expand our understanding of how matter behaves in interstellar space. Artificial confirmation would mark humanity's first verified contact with extraterrestrial technology, fundamentally altering our species' relationship with the cosmos. The cultural creativity inspired by 3I Atlas will continue evolving as our understanding deepens. Writers will craft stories about interstellar reconnaissance, galactic intelligence networks, and the challenges of communication across cosmic distances. Artists will create works that capture the mystery and wonder of objects that bridge the gap between star systems. Musicians might compose pieces that evoke the patience required for interstellar travel and the excitement of cosmic discovery. As 3I Atlas continues its journey beyond our solar system, it carries with it the hopes and questions of human civilization. Whether it eventually arrives at another star system for further reconnaissance or continues wandering through interstellar space for millions of years, it represents the cosmic connections that link star systems across our galaxy. It reminds us that we are not isolated in space, but part of a vast galactic community where matter, energy, and possibly information flow between stellar systems. Picture the gentle transformation of human consciousness that accompanies our growing awareness of cosmic visitors like 3I Atlas. We are becoming a species that looks up at the night sky with the knowledge that remarkable objects regularly visit our solar system, carrying with them stories of distant star systems and possibly evidence of galactic intelligence. This awareness encourages the cosmic perspective required for humanity's eventual expansion beyond Earth. The legacy of 3I Atlas will extend far beyond its brief passage through our solar system. It has demonstrated that remarkable objects regularly visit our cosmic neighborhood, that interstellar space is filled with travelers carrying stories we are only beginning to learn to read. It has challenged us to develop better tools for cosmic observation, encouraged international cooperation in space science, and reminded us that the universe holds wonders we have yet to imagine. As you prepare for sleep, carry with you the peaceful knowledge that 3I Atlas, whether natural wanderer or artificial scout, represents the infinite possibilities that await human discovery in the vast cosmic ocean that surrounds our world. In the gentle silence of interstellar space, 3I Atlas continues its mysterious journey, carrying with it questions that may reshape human understanding of our place in the cosmos. Whether this enigmatic visitor represents an unusual natural phenomenon or our first confirmed encounter with extraterrestrial technology, it reminds us that the universe holds secrets we are only beginning to discover. As you drift toward sleep tonight, imagine the patient watchfulness that such objects represent, whether the slow, natural processes that create cosmic wanderers, or the deliberate reconnaissance of intelligence that spans the galaxy. In either case, we are reminded that our small world participates in a vast cosmic story that connects star systems across unimaginable distances and timescales. Sweet dreams, and may your rest be filled with visions of interstellar travelers carrying the stories of distant worlds, whether through the ancient dance of gravity and cosmic chemistry, or the intentional exploration of minds that emerged under alien suns. If this cosmic mystery has sparked your curiosity about the universe's hidden visitors, please consider subscribing to our channel and sharing this exploration with others who find wonder in the night sky's secrets. Your support helps us continue these peaceful journeys through space science and cosmic discovery, bringing you the latest findings about objects that might be scouting our solar system from the depths of interstellar space. Until our next voyage among the cosmic mysteries, sleep well.